Yeah, I just thought I would make a video as I'm making the key. Why not? So, looking at this question on page 23. Um, Not a regression question yet, but this is just a word problem with the equation provided. And so a stone has become stuck on a tire, right? And if you were to, right, envision that stone, the height of that stone being stuck, right, would be represented by this equation. And time, right, the x variable is time, and the y is height, a second centimeters. So I went ahead, before I even start sketching, I figured out the period and the x scale. I just divided that, right? To get that, I just divided it in by 4. And so this is actually seconds, right? We're going to go up by 0.1086. So if it's a decimal, use 4, right? If it's a whole number, then no problem, right? Not a big deal. I get my max, right? I go D plus A to get that. Y mid, right? And then the Y min is obviously your 0 because you subtract the same number from itself, right? So that's a 0. So we have these three heights, and we have our x scale, which is very small, may I add. It also says that the graph must start at time equals to 0 and show 1 second, right? Label the maximum minimum values of your graph, right? And obviously, if you look at the period, it's less than a second. So that is probably because I borrowed this question off of a textbook or something, right? So to have a little bit of a variety, right? To be prepared for anything that is being thrown at you. So a second would obviously be 2 cycles worth of graph, right? Label the maximum and minimum values on your graph will be the height of the stone at time 1 second. We'll figure that out shortly. And so I just want to emphasize that the period in this case represents time, and that is seconds. So it's happening very quickly, right? So here we have everything we need. I went ahead and graphed this, and notice that your window, right? Your one period is 0.4, right? So 2 periods would be 0.86 something, right? So I went not just 1, I went 2, even though 1 would probably be good enough, or 1.5, something like that. And my y min, I go -1 because it's 0, right? And I went to 62 for the y max. And I had a graph, and there it is. And I found my first min, which is not quite 0. It's not quite 0. They want us to start at 0. So we are going to continue doing the same thing as before, using this as our starting point and then adding the x scale. But we also, maybe I will just go over here, because of this requirement, time is 0. They're basically asking for the y-intercept. So second trace 1, x is equal to 0, and we're just going to make sure we include that, right? So it goes second trace 1, x is equal to 0. And you need to understand that everything is connected that we're doing. And so don't be scared of some extra things that are thrown in there, okay? So I'm staying in the positive quadrant, in quadrant 1. So I'm just going to go ahead and graph this. I'm not even going below ground, right? I'm staying above. So here, this should be just enough here. So time in seconds, right? Height in centimeters. And we're good to go. And so I need to go all the way up to 60 and then a little sum past it. So if I go 20, 40, 60, 80, that'll do. 20, 40, 60, 80. And if you need it to split the remainder in half to help you out a little bit, you do that. And I'm going to go ahead and graph those. So 61 is right about here. So I'm just going to go ahead and mark that dashed line because it's going to help us graph this. And then we have 0, right? That's just our lowest. And our mid is 30, just above the 30 mark here. Yeah, it's a little bit more complicated without grids, right? But it should still be doable. So there you have your 3 lines that you're going to jump across. And you need to be very careful with your scale here. So I'm going to try to fit in 1 here, right? So I don't know, I'm going to use this as my marker here. 4. I'm going to make this stretch be 1 second. Right, this is 1. So this is 0.5 here, halfway, 0.25, 0.75. Split it even smaller, right? Half of all of those. So this would be 0.25, 0.75, right? This would be 0.125, right? And this would be 0.375. Right, because you just add your 0.25, you take 0.25 plus 1.25, sorry, plus 0.125, because you've established that one stretch is worth this much. So you just keep adding that to it. So this would be 0.625, and this would be 0.7, this would be 875. There we go. So you have that split up like that. That should help you out. That's how I did it. You don't have to do it like that. You can go up by 0.1 if you'd like to. Maybe that would have been a better idea, you know, in retrospect. You know what? I'm actually, yeah, that's probably a better idea. But anyways, so this is how I did it. It's a consistent scale. Let's just go with it. So I'm going to start with this and then later introduce this point into my graph here. So 0.02, that's so close, we can just make it almost touch. And then we're going to keep adding, right, this much to this value here, okay? So some of you probably like to stick with this method, right? And so we're going to come up with some more points here. 1, 2, 3, 4, 5. So we're going from 0 to 30, 1.79 to 61.58. There to 31.79 back to 0, right? So that'd be one cycle. And just keep adding the scale to it. So 0.02 plus 0.1086, that's 0.1286 plus 0.1086, that's 0.32372, and then keep doing that same thing over and over. 3, 4, 5, 8. Right, keep doing that, and you technically need another 4, right? Another 4 points to continue this, right? So I'm just going to do that now. 0.563, 0.6716, 0.7802, 0.8888. Okay, and I kind of assumed, right, middle to the top, back to the middle, and back to the bottom, which is 0. Right, so there you have your 9 points. So I'm just going to use this. That's my first one. Then 0.1286 is just past that. 0.23 is just short of 25, right? And then 0.34, that would be right about there. And then 0.4544. That'd be right about there. Okay, and just make it look symmetric, right? At the same time, 0.563. 563 is right about there, and 0.67 is right about there. 0.78 is right about there, and 0.88 is just past that. Okay? And then we'll make sure to include this point, and not much higher up, but there it is, right? Oh, we were supposed to go all the way up to 1 second, right? Or not necessarily. Oh yeah, it does say start at time 0 and show 1 second. Label the maximum minimum values of your graph. We already done that on the side, so we'll just leave it. So my guess is that, right, as it goes up, if we add 2.88, another 1086, we're going to be just short of 1. It's actually, it would round to 1. So we're just going to jump to here and make that be it. I have a feeling that they would probably want us to round all the way up here, but they didn't put the 4 decimals in here. I think if we would have been given the 4 decimals, then you would have probably actually ended up with you know, a graph that starts right at 0, 0. So I wouldn't worry about this too much. I will make sure that, you know, if it's that close, that it would actually start right at 0, and then you just go from there. Okay, so we have all of this. The only thing missing, of course, is the equation minus 1.87 plus 30.79. Okay, there we go. That's my graph. And then for B, what will be the height of the stone at 1 second? So second trace 1, x is equal to 1, and then we'll figure that out. And so we have a pretty good feeling that it's going to be 30.79, right? According to this, because, right, we weren't quite at 1 earlier, it's a little bit past it. It's 3182. And I would advise to just use your calculator for that. Okay, so that's that. That's page 23. The average temperature as a function of time of the day, of the year in a particular city is given by the equation. There it is. Where T is the temperature in degrees and D is the day of the year, where January 1st is day 1. So we have day and temp, right? More specific, right? Temp and Celsius, degrees Celsius. So we've established that. Graph the equation on your calculator, state the coordinates of the first min and the first max, right? That's what they want. Again, when you graph, just follow my method and you'll be fine. Okay, so we are obviously going to start with the usual, right? We're going to figure out the period. So that's 2 pi over 0.0172. Okay. It's 365.3, right? 3015. But for all intents and purposes, we know that the period is supposed to represent 365 days, but you should be aware, right, that it's not exact. That's why every 4 years we have a leap year to make up for that extra. The fact that every year it's a little bit actually for a full year is a little bit more than 365 days, right? So that's what it makes sense that this is a period which represents a full year, right? In this case, we're starting in January, somewhere low perhaps. If you want to go that way, as the summer progresses, we're going to warm up, and then fall comes, and we come back down to December 31st, right? So that would be a full cycle there. So the X scale would be 365. That would be 91.3254 days. Okay. We're going to figure out the Y max, which is 5.19. I don't know if it's going to ask. It's not going to ask that, but this 519 is technically the median temperature. Half of the time it's going to be above this temperature, and half of the time we're gonna be below this temperature. Okay, so that's important. So this is our highest temp, our Y mid. I'm gonna put that here. That's 5.19, and our Y min is gonna be 519 minus 1635. It's 2154. And this is a negative 11.16, right? We have that. Those are our three Y values that we're going to jump around. This is our X scale. It's our period for everything we need. So we're going to graph now. We are going into the negatives, right? So we need to account for that. Let me zoom out a bit. We're going all the way up to 20 something and then below negative 10-ish. So I'm kind of going to do this just a little bit more. I'm going to make my x-axis be right about there. Actually negative, yeah, there we go, negative 11. So this is going to be my graph. Time and days. And this is temperature in degrees Celsius, right? And I'm going to split this up into, this is my 0 here. This would be 5, 10, right? Negative 10, negative 15. That's how I do it. And then let's see if it works up 5, 10, 15, 20, 25, right? So 10, 20, there we go. I have that figured out. So this is 2154. And then I have negative 11. There we go. And my median is 519, right about there. I guess it's important to make sure the lines are somewhat parallel to each other. And we start with our, I'm thinking 365. If you want 2 cycles, what does it say? I think I'm just going to stick with 1 cycle here. Okay. So I'm going to say this is 50, 100, 150, 200, 250, 300, 350, 400. So that's how I'm going to run this, and I may have to change it, but here we go. So you type this in. 0172x minus 1.8404 close bracket plus 5.19. There's nothing behind it. Make sure. Oh, and I'm forgetting something really important. I'm forgetting the x there. window. I'm going to make sure my X max goes out to 400 and my Y min goes to negative, let's say 12, and my Y max goes to positive 22. And there is one cycle right there. So we're going to start with January 1st, perhaps, or let's try the first min, so second trace min. That would be right, left, right. So that's 15, right? So we're going to start with that second trace. And why am I not starting with a max, right? Because, well, January, if you're starting with January, if this is days, then it would make more sense, wouldn't it? 15.6746, negative 11.16, right? And so we're going to jump from there to 519. I'm just going to fill this in. So 1, 2, 3, 4, and 5, right? So this would be 2154. So you're going from the min, mid, max, back to mid. And this is back to the lowest point, right? That's actually it. This was irrelevant here. So we have our 5, and I'm just going to quickly. And this is the reason why I'm keeping all decimals, because that's, if you round here and round later on, if you were to actually try to find these points on the calculator, they wouldn't quite match, right? So we go this plus our X scale is 91.3254. So this is actually exactly 107 here. Wait, min, mid. This is my mid. This is 107. What did I do there? Min, mid, max. So I'm going to add a 91.3254. This is 198.3254. This is 289.6508. This is 380.9762. Okay, so we have that. So this would be 50 for me. I'm guessing 15 would be right about there. And then 107, right about there. And then 198, right about there. 289, right about there. And 380 would be here. Okay, so we're not quite starting. There we go. And we write down the equation. Okay, so there's one cycle of it. And we know that from here to here, that represents 365 days, right? And you got to understand every climate is different. Every part of the every climate zone is different, right? So that's why it might not quite start at time 0 or 1, whatever. But this is how it would be modeled in this scenario, okay? B, what does the period represent? That's the meaning of the period, right? The number of days right? It takes for the temperature, the average temperatures, to go from the lowest to the highest and back to the lowest. You can also say that's the amount of time for a full year. The number for a full year, because in this context, we understand, right, that from here to here, that'd be the number of days for something to repeat itself, and within this context, it's the days for a full year, right? We're going to get back to that. What is the first day? The average temperature of the day is about 10 degrees Celsius. So we're going to go y2 is equal to 10. Second, trace 5. We're going to figure that out. Graph it, and so this is the first instance. We're going to go intersect, and we're closest to it. So that's 124.36. And so we have to translate that a little bit. Let's say it's about, 30 days per month. Actually, I don't know if I want to get into this, but January has 31 days. February has 27 to 28 normally. March has 31. So this already gets us to close to 90. April would have 20 days. Okay. So if they asked for the exact day, right, then we would have to figure that out. But we could just say on the 124th day. And so if we go, I want to calculate that exactly, 124.36 minus January, February, that's already 62, minus 28, that gets us to 34 actually, right? 34 days remaining. April has 30, right? So we are actually in the May region, so it's actually going to be between May 4th and May 5th, right? May 4th or 5th. And I wouldn't expect you to know that unless I would give you that piece of information. Okay. So that's not D. For how many days of the year is the average temperature below freezing? That's what D is asking. And I ran out of room here. I'm going to answer D here. So we're just going to figure out, right, zero, below freezing would be below 0. So second, trace 5. We're going to figure out the 2 times that it happens, right? Time 1, time 2, and figure out the difference to determine that. Here it is. So second, trace 5. We're going to figure out this one first. And that's 88.2198. And find it again. Jump lines right across here. And that is 308. You can see that 308.4309. Okay. Now you have to be careful. If you find a difference between the two, you're actually going to find the number of days that it's above freezing. We want below freezing, right? So I'm going to use this method here where I go delta time. I will figure out the difference between the two. And that's 220.2111 above, days above freezing. Okay, that is above freezing. So we want time below. We take the period, which is we already established as 365.3015 minus 220 and so forth, right? So here it is. That's 145.09 days. Okay, I'm going to highlight that so that it stands out. Days below freezing is right there. Okay, so I figured that out the long way, or that's the way to do it if you want to do it the quickest way possible. All right, hope this helps.